Assalamu alaikum. My name is Shagufta, and we are going to discuss about chemical energetics today. This is the first lesson, so in which we will talk about exothermic and endothermic reactions. For any chemical reactions, there is an energy change. The transfer of energy, we usually represent it by delta H sign. In most of the reaction, energy is given out, and in some of the reaction, energy is taken in. For example, when petrol burns, heat is given out. When some of the salts get dissolved in water, heat is taken in. So there is certain change when we say that there is heat given out or when there is heat taken in. So obviously, these two are the two different types of reactions. If we touch the beaker where the reaction is going on, it's hot. It means energy is given out. So we call it exothermic reaction. If in any reaction, when we touch the beaker where the reaction is going on, if it is cold, it means it's taking the energy from the surrounding. So we call it is endothermic reaction. Surrounding involves, for example, if you are having the reaction in a beaker, so surrounding involves air around the beaker, thermometer, which is dipped in that mixture or in the container, or maybe a stirring rod, which is there, right? So these all comes in surrounding. So when the surrounding temperature increases, we call it's an exothermic reaction or exothermic change. So we can say when there is temperature rise or increase in the temperature, that is exothermic. So heat is given out by the reaction mixture. Hence the surrounding increase in temperature. When there is a temperature drop or decrease, so we call that type of reaction endothermic. We may have the physical changes in terms of exothermic or endothermic, like boiling. It takes in the energy from surrounding or evaporation. So that is endothermic, right? And when we change vapors into liquid, so it is releasing the energy. So that is an exothermic change. For any chemical reaction, bonds must be formed and broken. For example, in the given reaction, in iron and copper sulfate, that is a displacement reaction where iron, being more reactive metal, is going to displace copper from its solution. So obviously the bond between copper and sulfate ions will be broken, and the new bonds between iron and sulfate will be formed. So whenever there is a bond breaking, so it involves the energy change. So there is a difference because when the bonds are formed, that is always exothermic, and when the bonds are broken, it is always endothermic. It takes in energy. Then what is um, delta H? So delta H is basically the enthalpy change, the energy change. We have to check whether more energy is taken in or more energy is released. So we decide accordingly. Now, the normal examples for exothermic and endothermic reaction around us are combustion, respiration, and neutralizations are exothermic reactions, while endothermic, we have thermal decomposition of different compounds and dissolving of some ionic compounds. So that is endothermic reaction. It takes in heat from the surrounding. We represent energy change with the symbol delta H. So delta H means heat change basically. So we are going to talk about now energy profile diagram. So what is an energy profile diagram? It's a plot of energy changes against time during a chemical reaction. So for both the reactions, endothermic and exothermic, we have different diagrams. For example, you can see that the reactant energy is higher in exothermic. So it has a lot of energy. It has to release the energy to form a product. So, but there is a barrier in between. Before converting into product, it has to cover this barrier, which is called activation energy. We represent activation energy with the arrow on both the sides or upward arrow. Now, on the other side, for endothermic reaction, reactants are at a lower energy while products are at a higher energy. So it has to absorb this much energy, which is given in red, right? So that is basically delta H. Red one is the delta H. Now we have to show for the exothermic reaction, the arrow which have to use for the delta H, it should be downward, and for endothermic reaction, it should be upward. But for the activation energy, that is the blue one, we can use the arrow by giving the direction on both the sides or just the upward one. It means activation energy is always positive. So, what is activation energy? Basically, activation energy is the minimum energy which should be possessed by the molecules to be converted into product, because every collision will not give us the product. Only the activation, the particles having the energy equal to activation energy or more than activation energy will give us the product. Now just see the animation of the neutralization reaction. So I'm going to just demonstrate the reaction between hydrochloric acid and sodium hydroxide. Here the thermometer is dipped in a beaker containing hydrochloric acid. When we are going to mix, it's a neutralization reaction which is going on. So we can see there is a temperature rise. So it means that this reaction is an exothermic reaction, right? Now, next one is the reaction between sodium carbonate and ethanoic acid. So you can see that the temperature is shown on the thermometer. Now, when we mix it, let's see what's going to happen. So we can see that there is a temperature drop. So it means this reaction is an endothermic reaction. Now the next animation is about the energy profile diagram. So we can just change that energy. Okay, I'm going to change the energy of the reactant or product. So let's see what will be the effect on delta H and activation energy. Now just see that reactant is at the lower energy and the product is at the higher energy. So we can see that delta H is greater than 0 at that time. Okay, let's see. Again, it's an endothermic reaction. Delta H is greater than 0. All right, that is, it has to absorb the energy to be converted into product. Now, if we just increase the energy of the reactant and the product energy is decreased, now you can see that this one is an exothermic reaction where delta H is smaller than 0. It has react when reactant is supposed to be converted into product, so it has to release that much energy, which is represented by delta H, right? So it has to release the energy. So delta H, if in the equation it is given with the negative sign, it means that the reaction is exothermic. If it is given with the positive sign, it means that it is endothermic. That's all for today. Your first lesson of chemical energetics is done. Now, inshallah, I'll upload the second video for your lesson 2 of chemical energetics soon.